This is the screencast for section 4.3, example 7, using one trig ratio to find the others. So we're going to find cosine of theta and tangent of theta by using the given information to construct a reference triangle. So far all they gave you was that the sine of theta equals 3 over 7. Well, the sine can be positive in quadrants 1 and 2. Remember, sine is the opposite over hypotenuse. Opposite is our y-coordinate, and our y-coordinate is positive in quadrants 1 and 2. So far, this could be Q1 or Q2. But now I see that the tangent of theta has to be less than 0, so negative. And tangent is negative when the x and y coordinates are opposite. The opposite and adjacent sides are opposite signs. So that could be quadrant 2 or quadrant 4. So quadrant 2 it is. So already I have eliminated all possible quadrants except for quadrant 2. So I'm going to draw my reference angle in quadrant 2. And I don't know exactly what point I'm dealing with on the terminal ray here, but I know that the sine of theta, so this is technically theta, but its sine is 3/7. So if I use my reference angle inside here, its opposite over hypotenuse is 3 over 7. So to find that third side, I'm going to use, let's see, 3 squared plus, that's going to be my x-coordinate squared, equals 7 squared. So I got that my x-coordinate is going to be 2 square root 10, which I put up here as negative 2 square root 10. So now the problem is asking me for what is the cosine of theta. Well, the cosine of theta is going to be the adjacent over hypotenuse. So that's negative 2 square root 10 over 7. And then the tangent of theta, I already know that it's going to be negative, but specifically it is going to be negative, let's see, that would be opposite over adjacent, oh yuck. So that's going to be 3 over negative 2 square root 10. Well, I need to rationalize the denominator, so I'm going to multiply by square root 10 over square root 10 and get rid of that square root in the denominator. So that's going to be 3 square root 10 over, let's see, negative 2 times 10, which is so 20. So 3 square root 10 over negative 20. Ew, yuck. Part B says that the secant of theta is 3. So if secant is positive, cosine is positive. And I know that that can happen in quadrant 1 and quadrant, let's see, cosine here is adjacent over hypotenuse. The adjacent to a reference angle would be the x-coordinate. So that would be when the x-coordinate is positive, that's going to be in quadrants 1 and quadrant 4. Alright, and then the sine of theta is positive. Well, I can tell you already that that's quadrant 1, so we have a winner, but as we discussed in the previous example, that's also quadrant 2 as a possibility, but quadrant 1 it is. So since secant and sine are both positive, our terminal ray is going to be in quadrant 1, and it says that the secant of theta is 3. So the secant is I'm going to pick any random point on that terminal ray, draw my reference triangle, and then secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. So the hypotenuse is 3, the adjacent is 1. I can do a little quadratic or Pythagorean theorem off to the side. I'm finding the y-coordinate this time. So the cosine of theta in this case, let's see, that's going to be adjacent over hypotenuse, so that's 1/3. And then the tangent of theta is going to be opposite over adjacent, so that's 2 square root 2 over 1, so that's just 2 square root 2. In part C, cotangent of theta is undefined. So that means the denominator of cotangent has to be 0. Well, let's see, cotangent is adjacent over opposite, so the opposite coordinate has to be 0, which means the y-coordinate has to be 0. So that's going to be anywhere on the x-axis. Then if the secant is negative, secant is hypotenuse over adjacent, so the x-coordinate has to be negative, so this is going to be quadrants 2 and 3, which means the negative x-axis it is. So I'm going to draw my initial ray, and then my terminal ray on the negative x-axis, because it says cotangent of theta is undefined, so we had to be on the x-axis, specifically between quadrants 2 and 3, so secant is going to be negative. So I'm going to pick the easiest point I can out here to help me with this quadrantal angle, and that's going to be -1, 0. So the cosine of theta is going to be, let's see, adjacent over hypotenuse, so that's going to be the x-coordinate over 1, so that would be -1. The tangent of theta would be opposite over adjacent, so y-coordinate over x-coordinate. The y-coordinate here is 0, x-coordinate is -1, so that would be 0. Now if you notice, I found all of these trig ratios, the cosines and tangents of all of these thetas, without even knowing what those thetas were. Now, in a future section, we will be finding out what that theta was, but only by knowing the ratio of the sides you can determine fully what is happening in the triangle. The other side, the angles, the ratios between the sides. You don't even need to know what the angle is. Then now try problem number 43, says find the sine of theta and tangent of theta if the cosine of theta is 2/3. So cosine is positive. Cosine, x-coordinate, positive. So that's possibilities of quadrants 1 and 4. And then cotangent is positive. So if cotangent is positive, both the x and the y coordinates have to be the same sign, because a positive divided by a positive is a positive, and a negative divided by a negative is a positive. So that would be quadrants, let's see, 1 and 3. So I guess it's quadrant 1. So I'm going to put my terminal ray in quadrant 1. I don't know exactly where it goes, but I'm just drawing an estimate here. And so since this is theta, it says the cosine of theta, drawing my reference angle and triangle here, that's going to be 2/3. So the opposite is the adjacent is going to be 2, and the hypotenuse is going to be 3. Doing the Pythagorean theorem, 2 squared plus my y-coordinate squared is going to be my hypotenuse squared. So I get that my y-coordinate is the square root of 5. I don't have to worry about any negatives in this one because the x-coordinate and the y-coordinates are both positive. This point that I apparently picked on the terminal ray here was 2, square root 5. The sine of theta is going to be the opposite over hypotenuse, so that's square root 5 over 3. The tangent of theta is going to be the opposite over adjacent, so square root 5 over 2.